For this problem, we'll identify the graph of the conic section, and then we'll graph the polar equation. We have r is equal to 4 over 2 plus sine theta. So our first step in graphing this is to write it in standard form. Standard form will be r is equal to EP over 1 plus e sine theta. This is not in standard form because the constant 2, needs to be a 1. So in order to get it in standard form, we'll take each term of the original equation and we'll divide it by 2 on the right-hand side. So we'll have 4 over 2, 2 over 2, and sine theta over 2. Now I can write it in standard form. It becomes r is equal to, in the numerator we just have 2, in the denominator we have 1 plus, I'll write this as 1/2 sine theta. Now let's compare this equation to the standard form, and we can see that our e right here is equal to 1/2. So we can say that e is equal to 1/2, and e times p is equal to 2. If we substitute 1/2 in for e, then we get 1/2 p equals 2, and if I multiply both sides of the equation by 2, I get p equals 4. Now, in step 2, we can identify what type of conic it is based on the value of e. In this case, e equals 1/2, which is less than 1. When e is less than 1, this indicates we have an ellipse. Remember, if e equals 1, it's a parabola, and if e is greater than 1, it's a hyperbola. We now have an ellipse with one focus at the pole, and because p is equal to 4, we have a directrix, which is the line y equals 4. We know, based on our standard form, the 1 plus 1/2 sine theta, because of sine theta, we're going to have symmetry. In this case, the symmetry will be with respect to this line, theta equals pi over 2. And we know that we can simply choose the value of theta equal to pi or theta equal to 3 pi over 2, and we'll find out where the ellipse is along its major axis, which is the y-axis, or the line theta equals pi over 2. So let's let theta equal pi over 2 to find the first vertex. We'll make a little chart here with theta and with r. If we let theta equal pi over 2, if we substitute pi over 2 into our original equation up here, the sign of pi over 2 is just 1. So we really end up with 4 over 2 plus 1, or 4/3. So therefore, when our angle theta is pi over 2, we have a radius of 4/3. Let's also let theta equal 3 pi over 2. In this case, when we substitute 3 pi over 2 in for theta, we get that the sign of 3 pi over 2 is negative 1. So we have 4 over 2 minus 1, or 4 over 1, which gives us a value of 4. So when theta is 3 pi over 2, we have a value of 4 for our r. So therefore, we now have our two vertices on our major axis. Let's also let theta equal 0. When theta equals 0, sine of 0 is just 0, so 4 over 2 just gives us 2. So we have the point 2, 0, and by symmetry, remember, this line theta equals pi over 2 is our line of symmetry, so we have the point on the opposite side of that as well. And now we can draw a sketch of our ellipse. I'm going to label a couple points on this. This vertex is r theta, which is 4/3 pi over 2, and this other vertex is 4, 3 pi over 2. That's the graph of our conic section.